Thanks a lot.
Up next, we have Dr. Bdaiwi, of whom is a research fellow at the Center for Pulmonary Imaging Research at Cincinnati Children's Hospital. Dr. Bdaiwi's work ranges from non-Cartesian advanced MRI techniques, hyperpolarized gas MRI, image reconstruction, and integrating machine learning into medical imaging. He's particularly interested in developing innovative approaches to assess lung function and structure using hyperpolarized xenon MRI, one of which is going to be the topic of today's talk, which introduces software for loading, manipulating, segmenting, and analyzing lung MRI data. And personally, I had the honor of working with Abood for many years. I can call him a really good friend of mine. Super happy to see him here today, and it gives me great pleasure to introduce him to you all today. Dr. Abood Bdaiwi, please take over.
Thank you, Joey, for this kind of introduction, and thanks for the organizer for giving this opportunity to share my work with you. So today I'll be talking about xenon image processing pipeline, which I called here XIPline. So I just asked Copilot to generate the ES MRM there doing ziplining. So I don't know that if that counts within the bear hunting, but yeah. All right, so before I start with the package, I would like to just give a little bit of background about the hyperpolarization and specifically the HV xenon imaging. So xenon is one of the noble gases. It is safe to inhale, and it's one of the heavy atoms. It is a 26% isotropic abundance. And when you put it inside the magnetic field, the spins will, align based on their energy state. And then since the MRI signal is proportional to the polarization, which is defined here, so in the normal case here, the polarization will be really low and we cannot get a signal. However, what if we could somehow increase the polarization, which basically that's the polarization process, which is the process of creating an equilibrium spin polarization. So how do we do that? So basically, we add the xenon inside a cell with a rubidium, and then inside an oven, inside a small magnetic field, and then using a laser to deliver the angular momentum to polarize the rubidium first in a process called optical pumping, and then through the another process called spin exchange, they will exchange the spin with xenon, and then after that, we collect the xenon in a plastic bag, which we will deliver to the patient. This process can be done now using a commercial device by Polarian. So once we deliver the xenon bag inside the MR stand to the patient, they would inhale it, and we can do a couple of things with it. So usually we dose the patient around the tidal volume within less than 16-second breath hold, and typically we can image people 5 years and older. So what can we do with this technology? So first, we can look at the gas distribution inside the lungs, and we can identify all the defected area that the gas is not reaching there due to airway obstruction. We can also measure the alveolar airspace dilation through diffusion imaging. And then the nice feature about xenon, it can dissolve into the blood. And so we can measure the distinct frequencies in each compartment. And so we can generate images inside the airspace called ventilation here. And when it crosses the membrane here, and then when it binds to the red blood cells. And so we can generate these images in each compartment. This technology is limited to only a few sites, mainly in the US, Canada, UK, Germany, and Denmark, and a few other places. And we have a consortium, the Clinical Trial Consortium, and we meet every year to try to push this technology forward, and then also do multi-site studies. Xenon was FDA approved just last year in May, and here I'm just showing the images from the first clinical Xenon MRI in North America, which was performed in our site in Cincinnati. All right, so moving forward now, we got a lot of advancement in this field, from coil design, polarization, sequence design, image reconstruction, and analysis. And as the number of sites continue to grow, and then possibility of performing multi-site clinical trials, we need to do more standardization with data and analysis. In an effort to standardize the data, Peter Bosky, he put a great effort in publishing a protocol paper with the different sites, and that will include most of our imaging types. And then in our sites, we also put an effort to publish a pipeline to process these images based on the recommended protocols in Peter's paper. And so here I'm going and show you this pipeline that we developed in Cincinnati. And so here, the objective or the aim of this presentation is basically we developed an executable application to provide user-friendly graphical user interface pipeline to analyze hyperpolarized xenon data. So the toolbox was developed in MATLAB, specifically using the MATLAB app designer. And to opposite to Python, which is a great tools and open source and free to use, I chose the MATLAB for different reason. For example, it's widely accessible, it's very easy language, it's not, if not the easiest language to learn. And they have tons of documentations, backward compatibility. So if you have a 10 years old code, you can probably run it with minimal adjustment. No dependencies, hassles like Python, different versions and different libraries and so on. It's very close language, which is great. You can also develop stand-alone application, which does not require any MATLAB license. It only requires the MATLAB runtime, which is free to download. And some other things that everyone's is familiar with this language. All right, so the other question is, why not use already existing tools? Well, the xenon imaging is kind of different animal compared to the proton images. For example, here, the signal is diminished by with every RF excitation, because of that, we need to optimize our acquisition parameters like flip angles, frequency offset, TR, and etc. Also, scan calibration is not available on the major vendors. For example, the receiver or transmit frequencies, the shimming, and so on. Genetico does not address the xenon image specifically. For example, we have a specific step to analyze our data, loading the images, register the proton with the xenon images, perform segmentation, and then the subsequent post-processing for each imaging type. So we don't. There's no tools that can perform even half of these things altogether. And then again, when I started my PhD, there was no available tools at all. So we always have to write our own codes to do almost everything. Because of that, you know, just start from scratch basically and develop your own package. So that's what we did. So what can we do with Xenon? So as I mentioned, the Xenon, the XIPline support image analysis from all consortium acquisition protocols described by Peter's paper and all major vendors, Philips, Siemens, and GE. This will include calibration scans, the ventilation images with all subsequent analyses, and then the diffusion, again, with all subsequent analyses, and then the gas exchange as well. And again, all these analyses is supported for all major vendors. The application support all these type of data. So obviously we have the DICOMs, kind of universal medical imaging data type. And then we also have DAMAT, and then the NIFTY, which is kind of also very common in our field. And then also supports the raw data from all major scanner, and then also the ISMR MD format. And then here I want just to give a shout out here to the Xenon Clinical Trial Consortium tool that David, Peter, Matt, and Andrew put together in an effort to harmonize our analysis. So the XIPline in the background using these converters before doing the actual image reconstruction. So moving to the installation process here, it's just like any other program. All you have to do, head out to our GitHub here, and then you can, if you want to install the compiled version, which does not require MATLAB license. So you click on the installer, will take you to the repository, and then you can download the installer here, and then also the machine learning models to perform the segmentation that we developed for this specific application. And so here, for example, when you download it, you just run the installer and then choose the path you want to install it, and then just begin the installation. Once you finish the installation, you will have a shortcut here, just like any other program. Once you launch your application, the interface looks something like that. On the top left corner, you'll have the main menu, a few useful links and help documents. And then you have two main tabs. The first one is the calibration tab to perform the calibration analysis. And then on the top right, you have site vendor sequence kind of selection. This is to customize our analysis. And then you have the status bar to tell you updates and messages and sometimes errors in the background. And so you can kind of track the analysis. You also have this little light here on right bottom. So basically it's green is available and red if it's busy. The second tab here is for image analysis. And you can choose the type of analysis you want to perform here, ventilation, diffusion, or gas exchange. And then you can just follow these steps one by one to perform the analysis. And then we also added a denoising method using the BM3D method. And then we also added an option that you can perform all these analysis, all these steps all together or one by one individually. And then you kind of view the images in each step. We also have some tools here on the right that will help you to, view images differently and do some rotation and flipping that could be useful when you try to do this type of analysis. So for the calibration analysis workflow, we take the user input and then the data. Again, this data is based on the recommended protocol. And then we do the spectrum fitting for the gas and the dissolve to calculate the flip angles and then the frequency offset and the TR. And then the calibration analysis looks something like that. And then you can update the inputs here and then your result here, which you can use these number for the subsequent imaging types, ventilation, diffusion, and gas exchange. For the image analysis workflow, again, as I mentioned, you go through the steps, load in the data, do any manipulation for the image if it requires that, and then do the registration, segmenting the logs, and then do the processing depending on which analysis type, the ventilation, which multiple methods to do the VDP, the defect distribution index, and then the texture analysis. For the diffusion, again, multiple method to do the ADC analysis and then also their morphometry analysis. For the gas exchange, it's kind of a little bit hard-coded because it's very complicated analysis. But basically, spectrum fitting and doing the 1-point Dixon separation to get the RPC and the membrane maps, and then do the linear binary analysis. And then after that, everything will push into the result panel, and then you can generate a report after that. And so, for example, here, if you have Xenon images for this patient and you want to perform the analysis for this patient, all you have to do is load your Xenon data from here, and then your proton data. Again, all the data type, supported in this application, this version is shown here. And then once you upload your images, you click on load, the images will appear here. And then same thing, you can switch to the proton images and you can see them here. And then you move on to the registration. Again, there's multiple methods to do the registration. And then there's also manual edits that you can do if the registration needs to be updated. For the segmentation, again, multiple methods. You can do manual segmentation where manually you trace the lungs. It's the more accurate way, but it's also the most consuming time method. And then we also can have a threshold method, which can be useful sometimes, especially for the diffusion analysis. Most importantly, here we developed auto segmentation models as shown here. Specifically for this application. And you can see here, there's multiple 2D and 3D versions, and depends on the slice orientation, XLR, coronal, or single xenon or xenon and proton all together, single channel or dual channels. And then we also added vessel segmentation that can help improve the ventilation analysis. Once you have that, you have just to click what kind of orientation, and then just hit perform segmentation, and then we'll generate the mask for you. The last thing is the post-processing, and if you perform ventilation, and so all you have to do is click the box for the analysis that you want to perform. We also added bias field correction here, and some different methods of calculating the VDP, and then also the DDI, and then the texture analysis. For the diffusion, again, add your B values here, choose what type of fitting to do the ADC fitting, and then also we added linear band analysis here, and then the morphometry for both the cylindrical and the stretch exponential models. Lastly, for the gas exchange, we don't have many inputs here, again, because we hard-coded most of the analysis. It only requires to add the healthy distribution to do the analysis. And if you leave it on the default, it will take the healthy distribution from our center, but you also have an option to import your healthy reference as a .mat file, or you can just do manual inputs. And then after you finish the analysis, you can look at the analysis in the result tab, under ventilation here. You can look at any maps or histograms for any methods that you chose in the post-processing. Similarly, you can look at the maps for the diffusion analysis and for the gas exchange analysis. Finally, you can fill a report based on the result that you see here. And then you can generate a report, which basically generate a PDF for you with the info that you input here, and then plus the analysis outputs. So code structure. So all the skeleton and the GUI side of things is under the XIPline app file. And then the rest of the code is divided into modules or classes in each folder for each analysis type or analysis step, like loading data, registration, and segmentation, and so on. The code hierarchy is basically divided into functions. So the main parent functions for each image type, calibration, loading data, registration, segmentation, analysis is shown here. And then based on the user inputs, it will call the specific function to perform that specific task. Finally, this is completely an open source package. And so you can use the existing code that we developed, or you can implement your own code. For example, if you have a new data type that is not implemented there, you can just edit the code and add your a new data type, and then add the functionality to read that data here, and it should be good. The debugging side of things, again, the debugging is basically the same as you debug any MATLAB code. It's pretty straightforward and easy to do. However, we added a XIPline code script. This is mainly for debugging and implementing and testing new methods. This can run the entire application without the interface or the GUI side of things. So this is very helpful. I use it all the time to implement and test the new methods before I integrate it into the interface. And then the last thing, we have a user manual here. So if you go to the help and click on user manual, it will give you the PDF. This is about like 40 page document describing every single step of the analysis, how to perform all the steps or any kind of analysis. We also have YouTube tutorials, again, to how to install the package, how to perform any kind of imaging analysis, and also how to do developer mode to try to customize the application based on your need. Lastly, I want to just to play this video. And so here you can see here, I'll be performing the calibration analysis. First, we select spectroscopy, and then I'll leave it to the Xenon Consortium protocol, and then head to selecting data. In this case, I will select data from Philips, and then once you select the data, just hit perform calibration, and that will take a few seconds to perform. So you can see here the flip angle fitting, the gas and the spectrum fitting. You can update the inputs here, and then this one automatically would be updating, as you can see here, for example, doing 2D GRE or spirals, everything will be updated. And you can save the result here as a PDF in the same folder, the data folder. Now we'll moving on, clean the background of the platform, and then we can perform the ventilation analysis. Again, we'll just leave it on the default, the consortium, and then we will load our Xenon data. First, we choose what type of analysis, and then head and then to your data folder and choose your data. In this case, I will choose Nifty file, and I will tell you why. Because it doesn't have a header file, so the images will be flipped. And I want to show you how to use these tools on the right. So second, we will choose the anatomical data again. And then once we have those, we just hit load data. And then the data will appear on the window as you see here. You can scroll through the images, as you can see here, but you can see here the images are flipped, so we can use this nice tools on the right to flip the data to the right orientations. Once we do that, we save the changes that we did. Since we did that for the Xenon, we can do the same thing for the proton images as well. So we can just flip them to the right orientation, and then save the changes. And then the next thing I want to show a couple of these nice tools on the right on the Xenon image. And so the first one is basically just enable or disable this cross you see here. We can change the color of it for your liking. We can also change the thickness of the cross here. And then also we can change the window scale in here. This is very useful when you are working with 3D data. You can, of course, change the color map. That depends on how you want to look at the images. And again, you can use these tools to do rotation, flipping, swipe dimension, change the contrast, reset your contrast. And then you can also look at the pixel information for that specific slice. And you can see here, there's just two tools here, the box, which you can drag around, and then increase or decrease. And then you can also do some pixel measurements here. We also have a 3D viewer, or I would say ND viewer. This is very useful when it comes to diffusion images, because we have a 4-dimension here. And then finally, we go to the second step, which is the registration. Once you have your images, it looks good, and then you do the registration. That will take also a few seconds. The registration part, we perform basic registration in MATLAB, but we do have the ability to do end registration, which also will be available in the next version. And so you look at the registration, if it looks good, and then move on to the segmentation. And then, as I mentioned, we can do manual, we can do threshold, or we can do auto segmentation, which I will also be showing here. So we'll just keep it on auto segmentation, choose the coronal for this specific orientation, and then also choose the xenon and the coronal orientation for the vessels filter. Once you do that, you just hit perform the segmentation. This, what it does, it will call Python in the background, and then we'll perform the segmentation using the deep learning models, and then push it back to the package. As you can see here, you can look through the mask, make sure that it looks good. If it doesn't look good and some edits need to be done, you can edit the mask by hitting the edit mask, and then you can go through your slices, as you can see here. And for example, here, if I want to add something, for example, I want to add some missing part of the lungs. So this is fake. And then also if I want to remove the same part that I just added here. And you can go back or you can move forward. It depends on just, how you trying to fix the mask. And then you can just go through the slices and make sure that everything looks good. And then after that, it will be updated on the viewing window. Once you do that, that's it. You move on to the last part, which is the post-processing. And then here you, again, just click boxes for any type of analysis you want to perform. In this case, I selected all the methods for the VDB, and then the texture analysis, and then you hit perform. Again, that will also take a few seconds to perform some analysis in background, like calculate the SNR, performing the bias field correction, and then start populating the results. And so, for example, here you can see it's the ventilation analysis from the first method, which is the threshold method. And then after that, we will move on to perform the linear binning method. This is the linear binning method with the histogram shown here. And then moving on to the k-means VDB method, again, as shown here. And then the adaptive k-means. And the other last thing is the texture analysis, which is pretty fast. Once you finish that, then you can look at the result under the analysis results panel. So for example, here if we want to look at the coefficient variation map, you can change the color map to look at it. You can also look at the VDB map for the slices, and then you can look at the histogram. You can also do the same for the linear binning. And then the histogram. Similarly for the k-means as well. And then finally for the texture analysis. I think that's all I have for the demo. Finally, I just want to mention this. The next test for the XIPline is that we are working on using the consortium database to define the upper limit of normal from multiple sites. So far, we have more than 10 sites contributed to the database, and we have around 300 data sets now. And then we will be comparing using the package to compare all these different methods to calculate the BDP. So it'll be a nice test for this package. So finally, I just want to conclude. Basically, here we developed a user-friendly interface application to analyze the hyperpolarized xenon data. It is standalone application, so it does not require any MATLAB license. It's completely an open source for developers to customize the package for their need. And then also they can implement their own code as well. This is the GitHub repo, and then we encourage users to ask questions and then report any issues and collaborate with us to improve this package. Too many people to include here, but shout out to our center in Cincinnati, and then our collaborator in different Xenon sites, some funding support, and thank you for your listening.